Welcome. Section 8.4 today we'll be looking at trig substitution. So the idea is we have some type of square root and we'll be using some identities to make it easier to work with. If we have something of the form a squared minus u squared, we will use u equals a sine theta. If we have something of the form square root of a squared plus u squared, then we'll use u equals a tangent theta. And if we have the first one but flipped around, we'll use u equals a times secant theta. So our first example, we'll do the integral of dx over x squared, square root of 64 minus x squared. So here then we have x's instead of u's, so x equals instead of u equals. So a here is 8. 64 is 8 squared, so 8 sine theta. So dx then would be 8 cosine theta d theta. So plugging in what we know, dx, that is 8 cosine theta d theta. X squared would be 64 sine squared theta. There's x times x. And then we have square root of, we already had the 64 minus x squared, so 64 sine squared theta. Okay, so a little bit of simplifying to do. Integral of, I'll hang on to this 8 cosine theta d theta upstairs for the moment. I'll hang on to the 64 sine squared theta. We can factor a 64 from the first two terms. So we have root 64 square root of 1 minus sine squared theta. 1 minus sine squared theta is, of course, cosine squared theta. Okay, square root of 64 is 8, and I have an 8 upstairs. Those will cancel. I've got a cosine theta d theta. We have a 64 parked downstairs. We've got sine squared theta. And we have square root of cosine squared theta. Square root of cosine squared theta is cosine theta. And cosine theta at the top, those two guys will cancel. So we have the integral of, we can pull the 1/64 if it's easier, d theta over sine squared theta. So this would be 1/64 integral of cosecant squared theta d theta. And from our charts earlier on in chapter 8, we saw integral of cosecant squared, I believe they used u for the chart, u du was opposite of cotangent u plus c. So that's just from our table work. So this would be, we'll flip the sign, so negative 1/64 cotangent theta plus some arbitrary constant. Careful here though, we're not done yet. If you recall, the original problem was in terms of x. Right now we're in terms of theta. So this is where we want to make a quick little sketch. And in fact, I'm going to make it up here next to where I have my x equals statement. So if x is 8 sine theta, then equivalently I can also say that sine theta was x over 8. Sine, remember, is opposite over hypotenuse. So that means this guy is square root of 64 minus x squared. So negative 1/64. Cotangent of theta is cosine over sine, which will simplify then to adjacent over opposite. So root 64 minus x squared over opposite end is x, and then we have our plus c. So you can just use your drawing to get the cotangent back into the original variable x. All right, so our next contestant here, the antiderivative of, we have a dx upstairs and square root of 9x squared plus 25. So this one, we have the basic form of square root of u squared plus a squared. So we're going to use u equals a tangent theta. Instead of u, of course, we have an x. So 3x is the thing that's squared here. So 3x is equal to a 5 times tangent of theta. Equivalently, we can also say that x is 5/3 of the tangent of theta, which makes our dx 5/3 secant squared theta times, of course, d theta. All right, so I'll leave a little space there for my sketch later on. So we're looking at the integral of dx. There's our 5/3 secant squared theta times d theta. So that replaced our dx upstairs. Downstairs, square root of 9x squared is the same as 3x quantity squared, so that is 25 tangent squared theta. That is a messy 25, but this is a 25 nevertheless here. And we originally had a plus 25 next to it. So a little bit of cleanup here. I can get this 5/3 out to the front of the line. Integral of secant squared theta d theta upstairs. Downstairs we'll factor root 25. Then we have square root of tangent squared theta plus 1. And if you'll recall, secant squared minus tangent squared is 1. So tangent squared plus 1 is secant squared. You may also notice root 25 is worth 5, and I have a 5 upstairs and downstairs. So I've got a 1/3 out here, integral of secant squared theta d theta over square root of secant squared theta. So 1/3 integral of secant squared theta d theta over secant theta. You can drop one of those guys out. So now I have 1/3 integral of secant theta d theta. So for that, we'll recall from earlier in the chapter that integral of secant u du was natural log of secant u plus tangent u, close it up, plus c. So this is 1/3 natural log secant theta plus tangent theta, close it up, plus c. And don't forget, we can't walk away here. The original was in terms of x. The answer has to be in terms of x. So our nice pretty little triangle again. Okay, so I'm going to go with a version that'll have the tangent by itself. So then tangent theta for this one is 3x over 5. So if here's our theta, tangent, opposite over adjacent. So that'll make this guy square root of 9x squared plus 25. A squared plus b squared is c squared. So just Pythagorean theorem there at work. So then we use this to get our secant theta back and our tangent theta both back in terms of x. So a third natural log of secant theta is the reciprocal of cosine. Cosine is adjacent over hypotenuse, so it'll be hypotenuse over adjacent. Tangent, opposite over adjacent. So there is our antiderivative. Okay, our next contestant, integral of dx over 4x squared minus 5 quantity raised to the 3/2 power. So first off, I can make it look a little bit more like the other ones in this section. 3/2 basically means that this square root was cubed at the end. So 4x squared is 2x quantity squared, 5 is root 5 squared. So if you'll notice, the closest form we have is square root of u squared minus a squared. So u is a secant theta. So here then 2x is a, so that's root 5 times secant theta. So x is root 5 over 2 times secant theta, making dx derivative of secant is the secant tangent, root 5 over 2 secant theta tangent theta d theta. Again, I'll save a little space here to draw in our pretty little triangle later on. For the moment, let's get our substitution done. So dx is this hot mess here, root 5 over 2. Secant theta, tangent theta, d theta. And then downstairs, we have square root of 2x quantity squared. That would be 5 secant squared theta. So root 5 squared just makes it a 5, and secant theta is secant squared. And then we have minus 5, and then this whole thing is cubed. All right, so downstairs we can factor a root 5. So we have root 5 over 2, integral of upstairs secant theta tangent theta d theta. Downstairs, root 5 cubed. So I just factored a 5 here. It was still under the square root, and we still had our cube to attach. Square root of secant squared theta minus 1. Remember, secant squared minus tangent squared is 1. So secant squared minus 1 must be tangent squared. Square root of 5, I only have one of them here. I've got 2 of them down here, so I have 2 root 5s down there, which makes it just a plain 5. Also, we have this 2, so 1/10 at this point. So 1/10 integral of secant theta tangent theta d theta downstairs square root of tangent squared theta. Square root of tangent squared theta is tangent theta top and bottom. Goodbye to those guys. And these were, of course, then this was still cubed. So we knock that down to a squared. So tangent squared theta is downstairs. We had 3 of them, now down to 2 of them. Shorter way to write that is just tangent squared. So 1/10 integral of, so these would be easier to go to sines and cosines. So secant is 1 over cosine. And we're dividing by tangent squared, which means multiplying by its reciprocal. So 1/10 integral of, notice one set of cosines will drop, cosine theta d theta upstairs, sine squared theta downstairs. So then a little u substitution. So a substitution for a substitution happens sometimes when you move far enough along in calc. So u here will be sine theta. So du will be cosine theta d theta. So we have 1/10 integral of u to the -2 times du. So -1/10 u to the -1 plus some arbitrary constant. So -1 over 10u, plus c. So putting our u back in there, u was sine theta. So -1 over 10 sine theta plus c. And now we also want to get rid of our sine theta. So so that's where our drawing is going to come in to help us out with the sine theta. All right, so secant theta would be 2x divided by root 5. So secant is the reciprocal of the cosine, so instead of adjacent over hypotenuse, it's hypotenuse over adjacent. So 2x here, or root 5 here. So then this guy would be 4x squared minus 5. And under the square root then. So a squared plus b squared is c squared. So sine theta, opposite over hypotenuse. So -1 over 10 times opposite over hypotenuse, square root of 4x squared minus 5. And instead of putting this down here in the denominator, we'll go ahead and flip it, make it up here by 2x plus c. So -2x over 10 root 4x squared minus 5 plus some arbitrary constant. All right. And of course, we can drop that into a 1 and a 5. last one of the section. We'll do one with a definite integral. So we'll go integral from 2 to 4 of square root of x squared minus 4 dx over x squared. So this one we have the form square root of u squared minus a squared, so we're going to be using u equals a secant theta. So x is equal to a here is 2, so 2 secant theta. So then dx is 2 secant theta tangent theta d theta. Now you can either translate the x's into thetas, or you can just put in temporary placeholder variables for them, just dummy variables of calling them a and b and plugging them back when we're done. All right, so a little substitution. I'll stick with the just placeholder variables. Square root of x squared minus 4 squared. Hang on to that square root. X squared is now 4 secant squared theta. And we already have our minus 4 there. Over x squared again, 4 secant squared theta. And dx is the same as 2 secant theta tangent theta times d theta. All right, so I'll pull out square root of 4, or just 2. Secant squared theta minus 1 is left underneath for now. Downstairs I have a 4 and a secant squared theta. Out here 2 secant theta tangent theta times d theta. All right, so I have a 2 by 2, which is 4 upstairs, and a 4 downstairs. Goodbye to those fellas. Secant squared theta at the bottom, secant theta at the top. I can get rid of the secant theta at the top, turn the secant squared into a secant theta. Recalling that secant squared minus tangent squared is 1, secant squared minus 1 is tangent squared. So we have integral of square root of tangent squared theta times tangent theta times d theta upstairs. Downstairs we have our friend secant theta. So now we have integral of square root of tangent squared is tangent, tangent times tangent is tangent squared. So integral of tangent squared theta d theta over secant theta. And for this one, sines and cosines would probably be the easiest. So integral of sine squared theta over cosine squared theta. Dividing by cosine, or divided by secant, is the same as multiplying by cosine. And hang on to our d theta. So remember, secant is 1 over cosine. Dividing by 1 over cosine is the same as multiplying by cosine over 1. So we have integral of sine squared theta. These are all from a to b, are just temporary placeholders, the dummy variables. Over cosine theta d theta. So sine squared, that one we can turn into 1 minus cosine squared. Over cosine theta d theta. We can then split that up. So 1 over cosine theta is secant theta. minus integral a to b. Cosine squared over cosine is just cosine. So again, recall integral secant u du is natural log of secant u plus tangent u. Let's see. Antiderivative of cosine is sine. So we have natural log secant u plus tangent u minus sine. My apologies, those are thetas, not u's. Minus sine theta, all of this stuff evaluated from temporarily a to b. All right, so now we want to put our x's back in there. So it is sketching time. Okay, so x is 2 secant theta, so x over 2 is secant of theta. Secant is reciprocal of cosine. Cosine is adjacent over hypotenuse, so this is hypotenuse over adjacent. So that makes this guy square root of x squared minus 2 squared, or x squared minus 4. A squared plus b squared equals c squared. It's Pythagorean theorem. Okay, so then this would be natural log of, so secant theta, there's our x over 2, plus tangent theta, opposite over adjacent, sine theta, opposite over hypotenuse, and now I can put my bounds back in from x is 2 to x is 4. So then we've got natural log of 4/2 is 2. 4 squared, 16 minus 4 is 12. Root 12 is 2 root 3. 2 root 3 over 2 is root 3. We could use the absolute value. These guys are both positive though, so we can do it with or without the absolute value at that stage. And then we have, let's see, 16 minus 4, 12, so 2 root 3 over 4, so minus root 3 over 2. So, yeah, 2 over 4 reduces to 1/2. So that's plugging in our 4. Then we try out our 2. So we have natural log of 2/2 is 1. 2 squared is 4. 4 minus 4 is 0. 0 over 2 is 0. And then minus 0 again. So final answer, my apologies, I've sort of run out of room vertically. Final answer here, these guys, natural log of 1 is also 0. 0 minus 0 is 0. Those drop off. So then final answer, natural log of 2 plus root 3, close it up, minus root 3 over 2. All right, so some problems to try out from section 8.4. And I am going to leave you with the hints, so let me just flip this then. 8.4, 5 to 15 odd, 21 to 53 odd, and a hint on number 51, you're going to use integration by parts. And the stage where you come up with integral of, I think it ended up being 9 secant cubed theta d theta. Little integration by parts is necessary in number 51. Just a little hint, a little heads up. All right, get in touch with me with any questions. Otherwise, thank you and stay safe out there.